Hello guys, today we'll study biostratigraphy. As the name suggests, we can easily understand that it is the branch or it is a type of stratigraphy in which rock layers are studied and rock bodies are divided into finer layerings or finer divisions on the basis of biota, that means on the basis of fossil content. So it's the branch of geology in which fossils, that means ancient organisms, are used as the basis for stratigraphic divisions. Now the term biostratigraphy was first used in the year 1910 by the famous geologist Dollo. Now as the main concept or main target of biostraty is to divide rock bodies into finite divisions on the basis of fossils. So it is done primarily based on two principles of stratigraphy. The first one is the law of superposition, which states that in an undisturbed sequence of sedimentary deposit, the oldest layer are found at the bottom and successively younger layers are found on top of the previous one. The second principle or the second law of stratigraphy which is followed, that is the law of faunal succession or principle of faunal succession. Basically it is based on the concept of evolution of organisms, which states that organisms became changed through time. So one species evolutionarily changed to another species through time, and this changeover from one species to another species is one directional or unidirectional, and it is never reversible. So one species or one form, when they were gone from the record, that means when they are extinct from the earth history, they will never reappear or they will never came back during this entire 4.6 billion years ago. So if we follow the law of superposition and we move from older layers to successively younger layers in a undisturbed sedimentary rock sequence, as we move up through the rock sequence, we will get successively new and younger fossils. That is the main concept of principle of faunal succession, and on the basis of this principle of faunal succession and law of superposition, the rock layers or rock bodies are divided into finer divisions that we called as biostratigraphy. Now fossils are very useful tool because uh, fossils are preserved or ancient organisms are preserved only in the sedimentary rocks. In metamorphic or igneous rocks, preservation of fossil or preservation of organism is not possible. So in that sense, sedimentary rocks becomes very much valuable to us for getting the information of ancient organic world. Now fossils within the sediments of same age can be of different types, which may be due to the local variation in environmental condition. Say for example, a plant which we nowadays see in the mountain region, high hill region, cold temperature condition, such as the Himalayan region, and the plants which we see in the flatland areas or rainy forest areas, due to this environmental difference in these two areas, the plant bodies, although they live in the same time plane, they are different. So difference in organic body is resulting because of changing environmental condition. Again, similar kinds of lithology, that means similar kind of sedimentary deposition, is found in various depositional conditions, and those conditions, although they are uh, having the same lithological characters, they can be identified that those are deposited in different environmental conditions based on the fossil content. Say for example, sand deposit can be found in fluvial deposit, it can be found in aeolian condition, and also it can be found in the beach condition. So in all these three environmental conditions, the lithologic characters is same, but due to this environmental difference in environmental condition, the floral and faunal content of those areas are different, and on the basis of that organism characters, organisms assemblage, we can separate those environments, although they show same kinds of lithology. So fossils are very much useful to depicting the depositional conditions also, that means deposition and environments also. Now biostratigraphy is also important as an indicator of environment. So previously biostratigraphy is thought that fossils or organisms are changed through time, and this changeover is unidirectional, so that is why they never repeated through time. So that is why fossils are important to study, and they are used as useful tool for dividing a rock sequence. But nowadays, along with this uh, character, another character included in the study of biostratigraphy, which is also very much important, that is the indication or fossils used as a tool for indicating the depositional environment. And on the basis of these previous two, fossils are used as a general indicator of the relative age of geological depositional rock bodies. So in this case, for getting relative age, we basically used law of faunal succession and law of superposition. So in that sense, biostratigraphy is very much useful to us and very much important to us, particularly for the time frame when the organic bodies are very much available to the world scenario. And lastly, biostratigraphy is also very much useful in correlating geological sections. Now, during the study of biostratigraphy, that is when we are going to divide the rock column into smaller divisions, we have to know certain bio events. Bio events means these are some unique points within the entire geological time span during which some phenomena are happened which are not a regular phenomena. What are those phenomena? Those phenomena may be the first appearance of new species, first appearance of new higher order taxa. New higher order taxa means taxa above species level. Similarly, like the first appearance, there will be last appearance of new species, new higher taxa. That means higher taxa means uh, taxonomic labels above species level. So that will be first or last appearance of any taxonomic rank. Next is extinction of a species. That means a single species got completely dead due to some reasons. And similarly, mass extinction of multiple taxa, extinction of one species, or that may be higher taxonomic orders, higher taxonomic ranks, they are going extinct in a single time, and that is called mass extinction. Or another bioevent may be the appearance of um, multiple taxa, that is called adaptive radiation. When multiple numbers of species or multiple numbers of higher taxonomic rank they appeared very uh, shortly within a very small amount of time, uh, that means almost instantaneous, then we call them as adaptive radiation. So these are the major biological events by which we can uh, divide or we can classify the entire rock column into several smaller units. Here you can see an example. Here two fossils are there, fossil A and fossil B with time. Fossil A ranging from this to this. So first appearance data means the oldest record of fossil A. That means in rock record, when the fossil A first appeared in the rock record, that means the oldest record of fossil A. And here is the last appearance record or last appearance datum of fossil A, that means the youngest record of fossil A. Similarly, this one is the first appearance datum of fossil B, and this one is the last appearance datum of fossil B. So on the basis of these two fossils, if we try to classify this entire time span, we can classify them into three divisions. If we go from older to younger, in the first part, starting from here, that is the first appearance of fossil A, we can divide or we can plot a boundary here. When fossil B starts to appear, that means this entire portion is only consisting of fossil A. After that, at this point, fossil A becomes extinct. That means up to this point, from here to here both A and B co-occur within the rock body, and after that only fossil B is found within the rock body. Only fossil B is found within the rock body. So in the extreme bottom, only fossil A is there. In the middle portion, A and B both are there, and in the top only B is there. So you can see just by the presence or absence of one and more than one fossil groups or fossil species, we can divide the rock column into several smaller divisions. In this way, the rock bodies, particularly during the time interval when fossils are easily found or abundantly found in the rock record, the rock bodies are divided. Now, the biostratigraphic unit is a body of rock which is defined on the basis of its fossil content. And here, the biostratigraphic unit is different with respect to the lithostratigraphic unit on the point that in lithostratigraphic unit, the lithostratigraphic unit is the unit where lithology is the primary concern. Similarly, in biostratigraphic unit, biota or fossils are the primary concern for biostratigraphic unit. And for biostratigraphic unit, we are not at all concerned about the lithology. As you see in the previous diagram, there we divide the rock column only on the basis of the presence or absence of the two fossils. We are not considering the lithological character within that time span and in which lithology those two particular fossils are occurring. Only thing we are concerning about the fossil content. The fundamental unit of biostratigraphy is biozone, and a biozone is divided into subzones, that is the smaller divisions, or biozones can be grouped into the higher divisions, that is the super zones. Now each biozone has been given a unique name which is a compound name and designates the kind of biozone, that means the type of biozone. And most commonly the first word is coming from the common taxa or the assemblage of two or three taxas which are most commonly found within that zone, and the second part is uh, um, the name of the biozone, the different types of biozone. The different types I will come into next few slides. Now these biozones are defined by some particular type of fossils and they are known as zone fossils. Usually they are of species or subspecies taxonomic level. Now whom we called zone fossils? Zone fossils would be an organism which is abundant, which can be easily preserved in the fossil record. That means which have more hard parts, so which enhances the preservation potentiality, which have a um, huge ecological tolerance. That means they can be found in different depositional environments all over the world. That means they have a wide geographic distribution, and they must be showing a rapid evolutionary pattern or evolutionary trend. That means the evolution new form should be of very less amount of time, so that we can divide the rock column into more uh, finer fractions. So mainly five properties are there in the zone fossils: abundant, easily identified. They survive in all kinds of depositional environments, wide geographic distribution, and must show rapid evolutionary change. Now, there are different kinds of biozones are there. The first one is the Taxon zone, in which the biozone is defined by the first appearance and last appearance of a single taxon. Here the FAD, that is the first appearance datum, and LAD, last appearance datum of the same species or the single species, FAD and LAD, is taken into consideration to demarcate a particular uh, rock body into a biozone on the basis of a single taxon. That is why it is named as taxon range zone. Second is the concurrent range zone. Here more than one taxa is taken into consideration, and it is the common portion between two taxa. That means the portion of rock body which is defined by first appearance of one taxa and last appearance of another taxa. So between these two events, here, as I already told you, here more than one taxa is taken into consideration. So we are considering the first appearance of this taxon, which then continues through time, and the last appearance of this taxon. So this portion is the common portion between these two taxa where both are present. Below this portion, only this fossil is present, and above this portion, only this fossil is present. So only this is the common portion where these two taxa co-occur, and this is defined by first appearance of one taxa and last appearance of one taxa. So similarly, in case of fourth taxon, this is defined by first appearance of these two taxa, that means first appearance of some taxon and last appearance of other taxon. This common portion where all the four fossils are found, that is the concurrent zone. Concurrent range zone, that is the common portions between two or more than two taxa where both can co-occur, and the zone is defined by first appearance of some taxon and last appearance of some other taxons. Next is the partial range zone. This zone is also defined by first appearance of one taxon and last appearance of one taxon, but there is no common portion where both the taxas are co-occurred. Here you can see that this taxa last appear in the rock record here. After this point, the taxa become extinct, and this taxa starts its origin, that means first appeared in the rock body here. So in between these two taxa, a portion exists, this portion, this boxed portion, a portion exists where neither this fossil is present nor this fossil is present, and this portion is defined by the last appearance of this taxa and first appearance of this taxa. At the same time, it is defined by the presence of a third taxa, which is a long ranging taxa. Okay. So partial range zone is the body of rock located between the last appearance of taxa and the first appearance of another taxa, and there another taxa is occurred, that is known as partial range zone. Here no co-occurring between the two taxa by which the uh, by which last appearance and first appearance datum points are taken into consideration to draw the um, boundaries of the zone. These two fossils never co-occur. Next is the interval biozone. Interval biozone, here the biozone is depicted by the first appearance of two taxons. That means this taxa first appeared here and this taxa first appeared here. So the portions or the boundaries of this zone is plotted during first appearance of this taxa and first appearance of this taxa. So this portion is known as one interval zone, or similarly this can be drawn with the help of last appearance also. So this taxa last appeared here, this taxa last appeared here, and this portion is known as interval zone. So you can see that in this portion only this taxa is present. Below this there is no this taxa. Above this and this both taxa, this and this both taxa are present. So that is the only point, only portion in the rock body where you can only find this taxa. This is the interval zone. Similarly, that can be defined on the basis of last appearance of these two taxa. Next is the lineage zone, which is a biozone, that is a rock body in which it contains some species which have some evolutionary relationship, and within these rock bodies this particular biozone represents a particular time interval of those species. Here you can see during evolution from X, Y appeared during this time, then X continues some time and then gone extinct, Y continues to this level and extinct, and below that from Y Z appeared, Z continues, and after some time Y extinct. So all these three taxa X, Y, Z, they are evolutionary related. From X comes Y, Y from Y comes Z. So they are evolutionary related. And within this evolutionary tree, this is the time interval where the evolutionary phenomenons or evolutionary divergence or evolution changeover from one form to another form happened. This entire rock body, the lower boundary is marked by the changeover or by the evolutionary incident from X to Y, and the upper boundary is marked by the evolution from Y to Z. So it represents a body of rock containing species representing a specific segment of an evolutionary lineage. That means all these uh, taxas are evolutionarily related to each other. So this zone is known as lineage zone. Previously, interval zone, those are not evolutionarily related, but in lineage zone, these taxas are evolutionarily related to one another. They must have some sort of relation with respect to um, the other one. And the last uh, of the biozone in which more than one taxa is taken into consideration, that is the assemblage biozone, uh, in which is the body of rock characterized by the association of um, three or more numbers of taxa. Here a common portion where all the taxa co-occur. Okay. So you can see that during this blue blocked portion, all the taxas are occur. So this is neither this portion is demarcated by first appearance of a taxon or last appearance of, but during this rock body. During deposition of this rock body, all these taxa uh, occur. So that is why it is known as assemblage biogen. The last one, that is known as the acme biogen, which indicates that during some geological period there comes certain time frame when the abundance of a particular organism or a particular group of organisms certainly increase, and after some time the abundance of those growth organisms again decrease. They are present before that time and after that time, but within a short time interval their abundance is increasing. That means their abundance is not um, matching with the previous or after levels. Here you can see that a taxa is going through time, and during this time interval their abundance, that their diversity is increasing, and after some time again their diversity comes back to the background level and goes on. So that is the acme period, or most abundant period of this group of organism. That is why it is known as acme biogen. Say for example, whenever we heard the term dinosaur, the first word came into our mind, that is the Jurassic World. Now, dinosaurs are found in the rock record in the entire Mesozoic, that is from the Triassic, Jurassic, and Cretaceous. But why did Spielberg give the name of the famous movie the Jurassic World? It is because that during the Jurassic period, the abundance of dinosaurs reach its peak. That means that is the acme of dinosaurs. So that is why, that is the Jurassic is the acme zone of dinosaur. So that is why uh, Spielberg gives the name of the movie Jurassic World, and Jurassic is known as the acme biozone for dinosaurs. Now, apart from this, several particular type of fossil which is known as index fossil, that is not a particular fossil, but it is certain groups or certain types of fossils which can fulfill these criterias. What are those criterias? The criterias are those organisms which are abundant in the rock record, which are easily identified and easily preserved in the rock record. Most commonly, they are thought to be as microfossils because microfossils are highly abundant um, in the sedimentary bodies. But along with microfossils, macrofossils are also used as index fossils. Yes. Next is they have wide geographical distribution so that we can found a particular fossil in a certain age rocks in the entire world. Okay, and they must not be uh, restricted to a particular ecological condition. So that means they have a wide geographical uh, for wide geographical distribution. They must have a wide ecological tolerance also. So that is reason, as they have wide ecological tolerance, they can be distributed globally, and the most readily uh, global forms that can be distributed globally within a very short time, that is the planktonic forms, that is the floaters within the water bodies. They can float, and with the help of wind or wave they can move easily from one place to another. So they can be easily transported from one place to another In contrast, the nectonic and benthic form, they have to either swim or either crawl, so that makes them impossible to move across continents or across the large ocean bodies. And lastly, they must have short time span, that means short stratigraphic range, so that a minute portion of the rock record can be pinpointed, can be divided with the help of these fossils. So if these five criterias are fulfilled by any group of organisms, whether it may be a macrofossil, whether it may be a microfossil, it may be a plant, it may be a biota, it may be any kind of organic body which fulfill these five characters, they are considered as index fossil. So index fossil means they are the ideal fossils by which we can easily study biostratigraphy. That means by which we can easily classify, you can easily divide the rock records into finer divisions. And as these index fossils are showing global distribution, that means pandemic distribution, so with the help of these fossils we can easily correlate one section to other section, and that section may be few kilometers away, that may be that section may be of two different basins within the same continent, or that sections may be um, of two different basins of two different continents. So although they are spatially widely separated, but they can be correlated, and their relative age also can be estimated with the help of these index fossils. Now, the widely separated uh, basins, they can be good. So that is a very good uh, usefulness of index fossil. So that is why index fossils are very much useful to a stratigrapher. And nowadays, biostratigraphy plays a major role for stratigraphic divisions, particularly for any um, mineral deposits, particularly the crude oils, that means petroleum, hydrocarbons, or coal deposits, because these petroleum or coal, they are the products of um, ancient organic bodies. So that is why in every coal and petroleum basins, biostratigraphic study is a must subject, and biostratigraphy gain its importance day by day. So thank you. Hope you will able to understand from this short introduction. Goodbye.